Okay, what we're going to show here today. Now, yesterday we got everything. We got the basic stuff done. Where if you was on a job site, you can start cutting the rafters right away. Okay, you start cutting your king common for your 712. You start cutting your king common for your 1212. Your king and your hip. Okay, that's going to sit on the wall plate of the 1212 height. Okay, now this look kind of sloppy, but this camera actually is doing pretty good with getting a good shot of being able to make this stuff look legible. Okay, I'm going to write this correct so you can see that. So we see the length of this rafter, the common, the 712 common, in inches and in feet. It's the same measurement, it's just in inches and feet. We see the run in inches and feet for this same rafter here. Okay, we see the rise for this rafter from here to the top of here, from here, from there to the top of here. And we don't have it in feet and inches. It wasn't really necessary to put it in feet and inches, but we have it in inches. We didn't put it in feet. It wasn't necessary for that. This measurement right here is the run for the hip. Okay, we got it in feet, we got it in inches, and we also have the inches divided by 16.97, which gives us this answer. All right, that's really key. We got the height of this rafter here. The rise of this rafter, the total rise of this rafter here, from the top of the stands, from the top of the stands, it represented by this line, all the way to the long point of the plumb cut for the 1212 pitch side. Okay, we got that. Okay, and we just got that in inches. We didn't need to put it in feet. Okay, but we do have it in feet over here because this is the same measurement because it's 1212, and these numbers are the same, just like this number is the same. And this right here is 0.57 feet, which is exactly what that is. Okay, then we got the length of the 1212 rafter. This is the measurement for that rafter in inches, and this is the measurement for the rafter in feet. Same measurement, but we just have it in two different divisions, by feet and by inches. That's it. Okay, we got our secant here measurement. We get our secant measurement, which is 1.714. We get that. Well, I guess I jumped ahead of myself. What we should do, we extend this out for whatever the length of the overhang is. So whatever the length of the overhang is from the outside of the sheeting to the outside of the fascia. If the blueprints is calling for a 12-inch overhang, a 16, a 18 inch, a 50 inch, a 50 and 5/8, a 50 and 3/16. That's why I like this so much. I love this so much because of that. So whatever the overhang is over here, you do the same thing. And whatever the overhang is over here, you do the same thing. So I made this 16-inch overhang. So 16 inches, if you turn 16 inches into feet, it comes out to 1.333. And you take 1.333, add it to 0.574, and it gives you this measurement. Did the same thing over here. Took 1.333 and added it to 1.937, and it gives me 3.27. Then what I do is I take this number and divide it by this number, and that's how I get the secant measurement, which is this number here that I have circled, that I'm circling right now. Okay, after you get that secant measurement, you take that and multiply it by 0.574, and when you do that, that gives you how far your hip is from the king common, the side of the king common, all the way to the center of the hip. Okay, right? Then what we do, because now we get this, that's how we got this measurement. by multiplying this number by this number, and it gives us this number. Okay? And so now what we do is use the Pythagorean theorem and use this for the rise, and this is the run, or the run and the rise, so however you want to do it. Side opposite, side adjacent, side opposite, same thing. You said same thing. Okay? So you take this number here and square it. And we'll show you how to do that again, just in case you forgot, so you don't have to go all the way back in the videos and see that. So we're gonna do the Pythagorean theorem with these two numbers. This right here is basically a triangle. Okay, so this is going to be our rise for the triangle, and this is going to be our run for the triangle. Okay, so this is all we do. 0.574 squared. You can see exactly what I'm pressing on this calculator. Squared plus 0.984 squared equals, you got to press that equal sign, and then you press the square root sign. That's square and that's square root. Don't get those two confused. One is squared, you're squaring a number, and this is the square root. So now we're going to press the square root number, and look at the answer that we got. Uh-oh, something went wrong. Oh, no, it's right. So we squared this, we squared that, we square root in that and added these two together, and we get this measurement, which is 1.139. That's exactly what I got in the calculator. Then what we do is we take this number and divide it, and multiply it by 12, because it's 12 inches. We want to turn the feet into inches, and so it's coming out to 13.670. Then what we want to do is divide this measurement up, inches, into segments of 16.97 divided by 16.97 equals 0.805. You see that? So now we have solved the whole problem for the triangle in there. This triangle. Now what that affords us to do is we can figure out the pitch that we're going to and the cut that we're going to put on our 12-12 on our hip rafter, on our hips and our valley rafters. Okay, but in this case we're just dealing with hips, but it's going to be the same angle on valleys too. But anyway, so what we do to get that, what we do is we take this measurement right here, 6.89. Let's get that. 6.894, and we divide it. Okay, I missed the number. And the way you erase the numbers, 6.894. Okay, 6.894. And what we want to do is divide 6.894 by 13. That's 6.894 inches. We want to divide that by 13.670. Divided by 13.670. And just press equal. And you see it's 0.504. And that's why I have that there. That's our secant measurement. Now what we do is take the 0.504 and we multiply that times 16.97, because we broke up those inches. We divided the 13.670 inches by segments of 16.97, and obviously 16.97 is larger than that. So and we multiply it, and it equals 8.55. And that's our pitch. 8.55, 16.97. And if you look here on this framing square here, this 16.55 is like 16, it's like 8 and what I'm going to say 9/16. That's close enough. 8 and 9/16. So you're going to put your stair gauge, on like 8 and 9/16, and then you're going to put your other stair gauge, just put it on 17. 16.97 is 3/100 of an inch away from 17. So that's close enough, you know? And so that'll be your angle. So that'll give you your angle. Let's keep it moving. Let's keep it moving. I'm feeling good. Now let's keep going here. So now, since you got the 8.55, you already know what that is. You got that measurement by dividing this, the total rise that the hip and the king common, the 1212 king common, the wall height it sits on. That's how you get this measurement. You take that measurement and divide it by the run for the hip, and that is 13.67 inches. And that gives you the secant, 0.504. And then you take the 0.504 and multiply it by 16.97. And it'll give you 8.55. That's how you know that's how you can get your pitch and your settings for your framing square. Okay. Then what you do after you get these two measurements, then you just do the Pythagorean theorem. So we already got 8.55 in the calculator. Now we're going to square that number just by pressing square. And then we're going to plus 16.97. 16.97. And we square that. We press equal sign. And then we press the square root. We want to know the square root of that. And that is 19 inches. And you can see I got 19.05. So now to get the length of the rafter for the hip and or the valley, but in this case we're just dealing with the hip right now. To get the measurement for the hip, okay, you take this number and you take this number or this number, same number, and you multiply it times 0.805. 0.805 is 13.67 divided by 16.97. That's how you get this answer. So you multiply that times 0.805 equals, and it's 15.299. That's the length of this rafter. It's a really, really small, tiny rafter, okay? It's a really odd example, but the math works out. It works out on no matter what the dimensions are. So then what you do is you got that in inches, right? Now you change that into feet simply by dividing it by 12. That's how you change an inch into feet. You divide it by 12, and it equals 1.2749 feet. 1.274. I don't need the 9. Just 3 places is enough. So now we got the length of the hip in feet, and we have it in inches. Okay. Now, I think I showed you all that. We reviewed all that. You see how I got my hip here? We see how we got the 19.5. I showed you that. I showed you the secant, what that measurement meant. I've explained I see what I didn't explain. Now, okay, this 894 feet, 0.894 feet is the same thing as 11.808, which is 11 7/8 basically. Okay, 11 7/8 basically is what this is. Okay, and you measure from here to get your center. But then the other thing you can do, you take another way you can find your hip is by measuring the outside of the sheeting, the outside of the building line, and you measure over this way. You can find the hip by doing that, or you can measure it. It don't matter. And so what you do, you simply just take this measurement here. Let's clear this. This is the larger number, so that's the one we're going to be subtracting from, and this is a smaller number. So 1.937 minus 0.984 equals. I got 7 here, but it's supposed to be 3. 9.53 is what this is supposed to be. And I watched the video over and I saw myself writing 7, but was saying 3. I do that a lot. Some type of crazy form of dyslexia, I guess. Okay, so it's 0.953. Then what we do, because that's feet, we're going to put a feet mark. I even wrote it twice. 3. It's supposed to be 3. All right. So 0.953, we're going to turn that into inches by multiplying it by 12. And it's 11.436. We got 11.436. That's measuring from the outside of the building towards the 1212 side. And because the plate is higher, you're going to have to use probably a squeeze square or framing square to bring your mark up, or a level to bring your mark up to the top plate. And then wherever that plate is, and you want to make sure that the plywood on your framing runs all the way up to the plate, so you can put your speed square up there after you make that plumb line, like a plumb line, and then you can use your speed square to get the bevel for that angle. Now, we showed you that. That's really, really good. Now what we want to do, is we want to get the bevel. Well, should we do the bevel? Man, there's so much to do here. But let's see here. I'm going to show you now that I've reviewed everything. Now I'm going to show you another technique. This is a technique that I came up with. I don't know if anybody ever knows about this or do it this way or anything, but I really don't care. But this is something I came up with to help my mind out on a job site. Okay, so what we're gonna do is this right here. I want to show you something here. I draw as many graphs as possible so I can have a visual of what I'm doing, and it helps me to be able to process faster when I have a little schematics of what I'm doing. Okay, now this right here, it's not really even, but let's just say the overhang is the same, just for the sake of argument. Okay, so what we're going to do now, we know that this measurement is longer than this measurement. Okay, so since this measurement is longer than this measurement, that means that the hip is going to be swinging this way. On the 1212 side, you see that? See, it's not going straight to the corner there. Now, I like this right here that I'm doing. I'm going to show you this too. This is something else that I do. This is just something I came up with myself, just through studying and making it easy for me to remember on the job site. And when I'm planning my roof, doing the takeoff, ordering the lumber load, the whole ball of wax, I want to be able to know almost exactly what I'm going to need for the job site. Okay. Now this dotted line here represents the wall that the valley sits on. Okay. And I'm going to do another one here. The valley sits on here. That's why it's dotted, because I don't want it confused with the solid line. Okay. Okay. You see that? So this is an outside corner, but this is an inside corner. And this dotted line lets me know which way the hip has to go if there's an inside corner versus an outside corner. You see? Now what we want to do here, we know that this right here from the corner to this line is 14.436. So what we want to do is plug in, I mean, not 14, but 11. we want to plug in 11.436. All right. That represents how much. Now, this right here is the overhang, by the way, just to let you know. This is the overhang, and this is the building line here, or the outside of the sheeting. Okay. This is the outside of the sheeting. And the same thing with here. This is the outside of the sheeting, and this is the subfascia for the outside corner. Just to let you know that. Okay. So what you do, we got our 11.436, okay? And we want to write down what it is in feet and inches. And it is 0.9, boy, these pens are acting up on me, 53 feet, okay? Now, when you get this, okay, that solves for that. But what you want to know, and remember, my mark is to the center of the hip, from the corner to the center of the hip, just like I told you over here, from the corner to the center of the hip, which is essentially from here to here. Now, I know it's not to scale and everything, but this is 11 and 11.436. So about 11 3/8 to the center of the hip. Now, the other thing you want to do is, hold on a second, let me see, I think something's going on here. Okay, the other thing you want to do here, now you want to figure out what is the length of this. We know that this length from here to here is 11.436, but what is the length from here to here? And the way that you find that out is simply by doing this. Okay, you take this measurement right here, and we're going to take the feet mark, the feet increments, and we're going to go 0.574, okay, and we're going to divide it by 0.984. 984 equals. Okay, let me do that over. 0.574 divided by 0.984 equals. Okay, it's 0.5833. So basically what we have done, this line here represents the same line that's running here. Okay, this is just a larger, a full-blown angle of this same angle. And so what you do, since you already got this one, you divide it by this angle, which is this is the larger portion scale of this little tiny angle here. So this right here is proportional to that. And then what you do, and this is a secant, okay? When you divide this by this it equals this secant, okay? Then you take this secant measurement, 0.583 feet, and multiply it times 0.953. 953 equals, and it's 0.555. Okay, so the measurement here is from this corner of the building, the sheeting, all the way to the center of the hip. I'm going to plug that in. It's 5.555. Now that's feet. We want to change this into inches, so we know exactly how to read this on a tape measure. How you do that? You just multiply the feet by 12 inches times 12 inches equals 6.671. This is so beautiful to do it this way. So 5.555 is the same thing as 6.671 inches. Okay, That's what it is. All right. So now we got this measurement and this measurement, and we even know from this measurement to the center of our hip. Okay. So I do this all the time. So it's no little hanky panky business. It's no little hanky-panky business about what is this and that. I have a little piece of paper, or I do this on a block of wood the night before or a week before or whatever. And when I get to the job site, I got everything figured out, even the jacks. Now that I mentioned the jacks, I'm going to show you these jacks here. The jacks are very easy to figure out the jacks. What you do is this, y'all. You take the length of the rafter. Oh, you know what I got to do? Now, the reason why this little measurement here is really important, from the corner of the building to the center of the hip, the reason why that measurement is so important, I almost left out something. The reason why this is so important, because that actually, to the center of the hip on this side, is actually the actual run for this side. And you notice that we don't have any measurement for this side. Okay. We got a measurement over here, but we don't know what the measurement is for here. And the reason why we don't is because you got that little gap there. You see that? You got that little gap there, but you got to know what that gap is so you can add that little gap measurement to this measurement, whether you use the feet or inches. And when you add it to that, that's going to give you the exact measurement for this. So let's do it. Watch this. So we got the length of that was 0.555. Okay, we got 0.555, and we're going to add 0.555 feet to 0.574 feet. Uh-oh, I did that wrong. 0.555 plus 0.574 feet equals, okay? And our measurement is 1.12. Boy, these pins are not working. 1.29 feet. Okay, we want to change that into inches. So all we do is multiply it by 12 equals 13 inches, 13.548 inches. All right. Now, because we have the absolute perfect measurement for these two, you got your hypotenuse and your rise and your run. Now what we can do is figure out the jack measurements. Now we can figure out jack measure. And we're going to figure this side first. The way you do that is real simple. Look at this. Let me see here. The way you figure this out is this way, y'all. Look at this. You get the 26. You do the feet or the inches. It don't matter because we got both feet and inches for each side. So what you do is you take 20. Let's do feet. 2.2, which is here. 2.242, right? And you divide this, the rafter length, by what? 1.129 divided by 1.129 equals. Now this right here is your step off measurement. This right here is your step off per inch. I call it the SOFI. So 1.985 is your SOFI, which is step off per inch. That's what SOPI means, okay? SOPI. Now what you do is you take that measurement and you multiply it by 16. Why? Because each one of the rafters is going to be 16 on its center. So times 16 on center equals, okay, is 31.77. That's going to be the difference in each rafter. Now, what I should have did was first did it by 15.25. Get the SOFI, the step off per inch, 1.985 times 15.25, which is 15.25 equals. So your first is going to be 30.27. That's what you're going to deduct from your first rafter, which is 26.90. Okay. You're going to deduct that. So you deduct this 30.27 from here. And whatever you have left over in inches, every rafter after that is 31.77. So let me do this. 30.27 is, I like to write this. I say 15.25 is what I like to do. And I circle that. So I know that that's my first jack off the common, the king common. And then after that, this is 16 OC, which is 16 on center. So now I could figure out all the jacks right here. All I have to do to figure out all the jacks from right here is start deducting 30.27 from 26.90. And then whatever is left over from there, I go to 31. I deduct 31.77. Okay, but as you can see, these numbers here are larger than these rafters. You see that? So all you need is one rafter here because this is a really, really tiny roof. But I just want to show you the theory and the principle on how you would do this on a much larger roof, on any size roof. Okay, now how do you get the jacks for this side? Because now you're going to have jacks coming down here on this side going into this hip. Well, it's the same thing. What you do is okay? What you do is you get a point